Hello and welcome everyone. Just wait for like 1 minute. It's just we are going to start really soon. And welcome to for joining. And uh, just 30 seconds and we'll start. All right. I think we can start now. Hello and welcome everyone to our webinar World's Fastest LLM with Groq and SingleStore. My name is Yukti Trivedi and I'll be your moderator and host today. One of my main job at SingleStore is to organize weekly AI webinars and showcasing AI use cases. And I will post about upcoming webinars every week. I have not been doing that, but like if you want to stay on top of the loop, please feel free to connect with me. I'll start real soon. I've been having some issues with time. Also, I would love to hear your feedback for any ideas on new topics that you'd like to see on future sessions. So please feel free to DM me or anyone from the team. And we have amazing future sessions coming up. So speaking of future sessions, we have on May 3rd, we have AI ML driven forecasting for power demand and supply pricing. And then second is using AWS Bedrock and LangChain for private LLM depth. Everything is there on the screen. You can just scan the QR code and it will take you to our landing page. That's on May 2nd, the May 6th. And then we on 3rd, we have uh, live rack comparison test, Pinecone versus Mongo versus Podgris versus SingleStore on May 8th. If any of these topics sound interesting to you, please RSVP right now. I hope to see you all there. And coming back to today's topic, we are welcoming you to participate in the discussion throughout the session using Zoom. Through the bottom of your console, we have an internal mission statement to answer the 100% of audience questions, even if that means following up with everyone after emails. We also get a lot of questions, so please don't hesitate, ask away. We'll follow up with everybody, and we're up to the challenge. And make sure you have logged into the Zoom meeting with your name and email address because we won't be answering any anonymous questions. We'd love for you to try today's technology and have a dynamic experience. So anyone who tries out today will be entered to win either AirPods Pro or Meta's new Ray-Ban sunglasses. It's absolutely your choice. Simply click on the link that is there on the slide and you will be entered for the raffle. And you can simply log in and try SingleStore for having a dynamic experience during the webinar. And uh, definitely you'll have a chance to win any of these rewards. We have been having a free trial for many years, but in the past few weeks, we have had a new free share tier, which we'll talk about later today. So moving forward, let's announce today's speaker. We have Alexander Peng, who is a growth engineer at SingleStore, and his formal training was from Stanford Computer Science program, which is so cool in my opinion. And he has expertise in big data, machine learning, and AI. He's quickly becoming a regular speaker at our webinars on data and AI, and I'm so happy to have him here. Welcome, and thank you so much that you have joined. We also have Akmal, who is here to answer everyone's question. He's an expert here at SingleStore and is a technical evangelist, and he's had tons and tons of experience. Please feel free to ask away. Your questions are in good hands. So, all right, I think I'll hand over to Alexander, and yeah, the floor is yours. Thank you so much.
Thanks so much for the intro, Yukti. Yeah, so as everyone knows, today we're going to be talking about something pretty exciting. We're going to be talking about Groq, which is the newest kind of and world's fastest LLM inference engine, which is very recently been released. But before we really talk about Groq and all of these new novel LLM inference techniques, we really have to understand the kind of underlying architecture that we're seeing for LLM applications, and the kind of best practices that we're really seeing emerge for these LLM applications that we're all building, right? And that's really going to rest on this foundation of retrieval augmented generation. And so, just to give everyone the same level foundation before we really get into the weeds of things, retrieval augmented generation is the means by which we augment our LLMs, whether it's Groq or ChatGPT or Gemini or Claude, with information that was not made available to them during their pre-training process. And that information is going to be anything from PDFs to Slack messages to proprietary company data, maybe your personal data, whatever you'd like the LLM to be able to understand, because as we all know, LLMs have pretty annoying, this pretty annoying side of them where they'll hallucinate, and they'll confabulate and make up, facts and figures if you don't give them the right information or if you give them the wrong information, right? And so this whole process of retrieval augmented generation, whereby end users ask, or pass a query to our Gen AI or LLM applications, and then we pass that query, process it somehow, and retrieve the relevant information for the LLM to respond with in its context. That's actually a pretty involved process, and we'll be talking a little bit more about it today. But before we talk about that, we have to think a bit about the actual LLM that's powering the responses after we do retrieval, right? Groq, and I encourage everyone to try out Groq like literally right now. If you haven't already seen it, you can just type into Google Groq chat, and you can see how blazingly fast Groq is. And that's really going to be due to this proprietary technology that they've come up with called the LPU inference engine, which is a special chip that they've made specifically for LLM inference. And the upshot of that is that Groq is amazingly fast. So go ahead and try it. We'll also be taking a look at it in the live code demo if you're kind of just interested in sitting back. But just to give a sense of how fast it is in numbers, ChatGPT 3.5 Turbo is on the order of 200 to 300 tokens per second, 100 to 200 tokens per second. Groq can get up to 700 or 800 tokens per second. That's maybe up to an 8x increase in speed compared to a model like GPT-4, where you're maybe getting, anywhere from 50 to 100 tokens per second or 25 to 50 tokens per second. You're going to see latency drop like a rock, right? And that basically unlocks for you as an AI or LLM developer all of these use cases that were basically unusable or undevelopable before, right? Real-time analytics over, a fast-moving pipeline of, fresh data you can now do with Groq, right? Groq has a JSON mode, a structured JSON mode, which I can show everyone in the playground, but if you, I'm sorry, I just saw a hand go up. I can show everyone in the playground, but if you just go to the website, you can see, you can kind of constrain Groq as well to respond, and parse out certain fields or fill in certain fields based on input data, right? Some more like consumer level use cases. You can also see Groq unlocking, instant translation and instant voice chatbots, right? I don't know if you guys have, if any of you have tried, some of these translation services on longer pieces of text, for example, but it's pretty difficult to get it to work very quickly, right? Because say, for example, if you're trying to translate the entire text of, you're trying to translate the entire text of a book to, from say, for example, English to Spanish, right? You will very quickly run up into, some of these tokens per second limitations that we're seeing even with the most bleeding edge models, right? And then finally, we have, for maybe some of the more financially minded people in the room or in the webinar, Groq also unlocks some pretty exciting capabilities on the trading side of things. You can imagine, being able to parse through, say, for example, news headlines and parse through their sentiment on a specific company and be able to react that much faster based on sentiment that you're analyzing, not by hand, not by even bleeding edge LLMs, but by the world's fastest LLM. So how does Groq actually work under the hood, and what's powering Groq under the hood? Well, Groq itself is not actually a model provider or model trainer. They don't actually train their own models. They use open source models. And you can see when you go on their website, you can choose between a number of different models. There's the newest models available from Mistral, which is one open source model provider. But the model we're going to be using today inside of Groq is going to be Llama 3. And Llama 3, we actually just did a webinar on, actually just on Tuesday. So I would highly recommend checking that out if you're more interested in the details of Llama 3 and how to specifically use Llama 3. We're going to be, kind of glossing over the details here, but essentially Llama 3 is going to be the best, currently best available open source LLM, right? And that's going to mean that Llama 3 is going to perform, kind of pound for pound as well, if not better, than some of the best open source LLMs that have come out in the past year. And really, what we mean by pound for pound is that for the same amount of compute, right, Llama 3 is going to perform better, reasoning-wise, factuality-wise. It's going to use less graphics card memory. And so, if you want to run Llama 3 models locally, you totally can. And I would recommend checking out our webinar on Tuesday for that. But what we're interested in today is extremely fast, blazing fast inference. So, that's really only possible realistically, unless you manage to get your hands on, one of Groq's LPUs and bring it home. That's really only going to be possible over the Groq API. And so we'll be working with that today. Now that we've kind of understood the kind of model layer and the inference layer of this retrieval augmented architecture that we've been talking about, we really have to understand kind of top to bottom how it all fits together, right? And so, at the top and then, kind of flowing into the middle, if for those of you that have gone to the Groq website, you've already seen what this looks like, right? There's at the very uppermost level, uppermost layer where, most end users, business users are interacting with LLMs. That's going to be in your UI, right? That's going to be in your conversational UIs, your chatbots, browser plugins, SaaS applications, and so on. And where most of us live is in the world of API endpoints, right? We're hitting the Groq API. We're going to be, orchestrating agents and orchestrating LLMs, providing them access to tools via function calling, which themselves call other APIs, right? We're interested in actually applying some of these technologies, right? And then kind of foundation at a foundational level, powering everything and giving, the LLMs kind of the lifeblood of what they need to really be relevant and helpful is going to be that data, right? If we don't want our LLMs to hallucinate, we don't want our LLMs to kind of go off the rails, and we want them to be useful over data that is not easily accessible to anyone over, say, for example, Google search. If we want them to be useful over, say, our private, corpus or repository of code or PDFs or Slack messages, if we'd like them to be able to access that, we need a contextual data store. And, we here at SingleStore, we're biased. We think SingleStore is the best place to store your contextual data, especially for AI use cases. We call ourselves a database that transact, analyze, and contextualize in real time. And what that means is that SingleStore is blazing fast, right? We're capable, obviously, of traditional row-based, row-based and columnar, like relational database functions. So for data analytics, using SQL over a database, all super fast. And we've also had vector support and capabilities since 2017. And so vectors, for those of us that are unfamiliar, vectors are really the way by which AI is able to retrieve information that's relevant to a user's query using what's called semantic search. So instead of searching over your database by keyword, like say, for example, Google would, right? Matching exact letters to exact letters, we're matching meanings to closer meanings, right? And just here are some really quick metrics on a few of our customers. SingleStore is, on-prem, it's in hybrid environments and also multi-cloud. So, you can host it anywhere that you already have your cloud. And here's just a diagram kind of showing how SingleStore really works under the hood, right? So the way that we kind of get that blazing fast, industry-leading, query access and analytics speed is through a proprietary technology that essentially compresses the traditional database stack into one single database, right? Allowing data that is most useful, most relevant to flow to the top to in-memory, where it's very quickly accessed, and then data will automatically flow, to local disk, SSD storage, and then finally to cloud object storage. And you don't have to worry about any of those details as someone that uses SingleStore. You just get access to amazingly fast performance. And now we'll show how to use that incredibly fast performance of SingleStore alongside the world's fastest LLM inference engine to really unlock some crazy, really cool use cases for all of you. All right, don't want to skip over this, as this is actually what we'll be working on today. SingleStore actually has recently released a really cool functionality called SingleStore Notebooks. And that's going to be the best possible way to run code and run, Python notebooks as close to your data as possible, as close to your data inside of SingleStore as possible. It's a really cool interface inside of SingleStore that I'll show everyone in just a second here. It allows you to connect your notebook directly to your database. And so, you can get up and running in just one line of code inside of the notebook. You can get connected into your database in just one line of code. No fiddling around with, API keys or, connection details or anything like that. You can just get started right away. And yeah, just to summarize, SingleStore is the contextual database for Gen AI applications. We can do vector semantic search, but obviously we can also do traditional keyword search. You can connect and ingest data on the fly using pipelines. You can, do hybrid search with both semantic and traditional lexical search, which really kind of gets you the best of both worlds in terms of information retrieval performance. I will kind of I will kind of get us right into the code now today, as I'm sure all of you are very, very excited to see some of the cool use cases that are being unlocked here. Great. All right. Let's take a look at some of this Q&A first, actually, before I get into the code. Oh, we just got a question. Akmal, I think this might be a good question for you to answer. And I think this would be good to address before we get into the code. Sorry for catching if I caught you off guard there.
No, no, I was just trying to source some answers for some of these questions.
Yeah, so Bruno asks, can SingleStore support native live video stream, for example, CCTV footage, LiDAR, for frames per second, building context, and object classification on a time series reference for real-time trigger notifications and post-event lookups?
Okay. Off the top of my head, I I don't know, but I think we do. I mean, what I did not so long ago, very recent, I think within the last couple of weeks actually, was something demonstrating clip from OpenAI. So I was using the open source version and essentially taking a video from YouTube, breaking it down frame by frame, and I opted to use 1 second as the sort of time period that I was using. Generate embeddings from that, store that, and then ask queries of that both in textual formats, so as saying, okay, look for this particular text pattern, and also comparing against an image. So, you know, you have this kind of multimodal capability. So definitely the SingleStore can handle the storage, even the pixels, okay? So the RGB values, you can store those in the database system. Whether you could stream it, I'm sure you could. I mean, pipelines is awesome. You can connect to Kafka, lots of other sort of data sources in terms of as the kind of source where you're getting your data from, and simply connect to that. And if it's sending the data in some format that SingleStore can work with, should be easy. But great question. Thank you for that.
Yeah. And just to like echo that thought, Bruno, I think there's nothing in principle that stops you from being able to process, CCTV footage or a live video stream using SingleStore. Um, you know, it's just going to be probably about the actual, unlocking the actual kind of engineering details behind it. So, just off the top of my head, I would imagine you're probably pulling out, a frame every couple of seconds. And then what we've done actually is we've done webinars as well on how to do multimodal inference. So Akmal's done one. I've also done one using both LangChain and Llama Index, which SingleStore is SingleStore is integrated into both LLM orchestration frameworks. So I would highly recommend checking those out. If you pulled out a frame every second or every couple of seconds, you ran that through a multimodal LLM, which is able to understand, images, and then you asked it, like, hey, what are the, asked it if the objects that you're interested in are in the picture, right? And you save those frames, then you should be able to search over those frames afterward when you're interested in like timestamps and where those objects show up. But good question, actually. Okay. So let's take a look here. I wanted to show everyone how to get started here. I believe everyone should have access to the code. But let's just go ahead and get started here. Before we get too deep into the code, I wanted to remind everyone, we're going to be building a RAG application today. So we'll need a database, and so we think SingleStore is the best database to get started building on for Gen AI applications. We just released SingleStore free shared tier actually, which I'll be showing everyone how to use. But if you go to singlestore.com/cloud trial, or you go to the QR code at the beginning of the that we shared out at the beginning of the presentation, which also signs you up for the AirPods and Ray-Bans giveaway. If you go there, you'll get to this page. I would highly recommend signing up. And then once you've signed up, you'll get spit out onto this page here, the SingleStore portal. And from here, how you start a free shared tier workspace is super simple. Once you're on this page and once you've signed up for the cloud trial, you just go ahead into this cloud tab, you click group. And everyone should be able to see, I already have a starter workspace that I've started here. But If you don't yet have one, then this will not be grayed out. You'll be able to click it and you'll be able to start a starter workspace, name your workspace. Everything's going to look the same here. You'll select your cloud provider, and then you can spin up your starter workspace and get up and running. If you're more interested in, actually, I believe starter workspaces only host on AWS. If, for example, you're interested in hosting on, GCP or Azure, or you'd like to be able to customize, the size of your workspace, the compute of your workspace, you already know what you need essentially, then I would recommend starting a standard workspace. But once you have your workspace, here's how everyone can get started inside of SingleStore notebooks. I believe the code is shared out in the chat. Yes, it is. Okay, great. So once you've downloaded the code from the GitHub link in the chat, it's super simple to get it set up inside of SingleStore notebooks. What you're going to do is essentially go into actually one of these tabs here. I would just go into personal. And then you're going to click on this upper right hand button here, new notebook, this little drop down, import from file. And then you're going to go ahead and import the notebook that you've just downloaded. But I actually already have the notebook imported here. So let's just click into this. Once you've got your notebook set up and you're loaded into it, you're going to want to make sure not to forget to select your connection as well as your workspace. You want to make sure not to forget to select your workspace as well as your database. Sorry. And that's going to make sure that all of those connection details are made available to your notebook over the environment variables. So you can get up and running in just one line of code, and everyone can see how that's going to work in just a second. I'm going to go ahead and install some packages really quickly, just for the purposes of the live demo later. Usually we don't do we don't usually do live demos, but given that today is all about real-time inference and showing off the speed of Groq and SingleStore together, I figured it'd be good to show everyone that live. But before you get started, you're actually going to want to also make sure to have your Groq API key, and I'm going to show everyone how to do that here. If you just go to groq.com, you'll want to go to Groq Cloud, and you'll want to make sure you make an account first, and then you can go into API keys, and you can create an API key. It'll show you your API key so that you can copy and paste it, and that'll be your Groq API key. And not to worry if this is going a little too quickly for everyone. We will be recording the session and we'll be sharing it out in the follow-up email. So you'll need the Groq API key, and then we'll also be using, for our embedding model, we'll be using the OpenAI embedding model. And happy to talk more about embedding models. We did a recent webinar on fine-tuning your embedding model, which is, I think, a great resource for understanding kind of the nuts and bolts of how embedding models work, how to set up your own embedding model, and how to really squeeze the juice out of your own kind of open source embedding model. But we won't be using an open source embedding model today. We'll be using the OpenAI kind of off-the-shelf embedding model, and for that, we'll need an OpenAI API key. So for those of you unfamiliar, just inside of on the OpenAI website, you just go to openai.com/API. You can click Start Building. It'll prompt you to make an account if you haven't yet, and then you can go into this kind of left tab here. Click API keys, and then you can create a new API key or use an existing one that you already have. And you're going to want to make sure to enter both of those inside of their respective Python cells. So I'm actually going to go ahead and enter those now. Great. Okay, so let's see. We've got the API keys here. I'm just running some of these cells just to make sure that just going to make sure that all of this is working. Great. Okay. So once you've gotten your API keys imported inside of your Python notebook, now we kind of get into the actual code, right? And so for the code, we're going to be using LangChain, which is one of the LLM orchestration frameworks that SingleStore is integrated into. For those of you unfamiliar with LangChain, it's basically a very simple way to get up and running, get started prototyping LLM applications, using really simple abstractions that the LangChain team has already created, right? So, LangChain is integrated into Groq, and so we'll be using that to kind of interact with the Groq model. Here we've installed the LangChain Groq package, as well as the LangChain, as well as the SingleStore package and the LangChain OpenAI package, so that kind of all have all the pieces we need to get up and running. But from the LangChain Groq package, we're going to be using the Groq chat model. So that just means that it's the model that Groq uses. It's the model or the format of model that Groq has, or Groq makes available, that's going to be optimized for user chat and chatbot use cases. And when we initialize our Groq chat model, we're going to be using as our underlying model, we're going to be using the Llama 3 model, the one that we've just been talking about. We've also defined its temperature here to be 0, and temperature is essentially you can just think of as a measure of how creative you'd like the LLM to be. And if you're using it for RAG use cases, generally you want to set it to 0 so that the LLM kind of adheres to the context that you provide to it as closely as possible. And then to compare against the OpenAI model, we're also going to be using OpenAI's fastest available production model today, which is GPT 3.5 Turbo. And it's not going to be quite an exact comparison. We're going to be asking, Groq and OpenAI to explain the importance of low latency LLMs, right? And you'll see, you can see the responses here already, and we'll run them in just a second. They're not exactly the same, right? You can see already that OpenAI's response is much shorter. So you might expect that, OpenAI might even be faster than Groq here. But if you run the OpenAI kind of prompt and you ask it to respond, you can see it takes about 6 seconds to respond, and provide this kind of, slightly shorter response about low latency LLMs. But if we run the Groq model, in less than a second, we have, an even faster response, even more detailed response about the importance of low latency LLMs. So I don't know about you, maybe I'm just a nerd, but the first time I saw that, I was blown away. This really, the speed of this, it's not even a second, it's less than a second. It's on the order of milliseconds, hundreds of milliseconds, compared to, 6 seconds or more, right? The speed of this is just absolutely incredible, right? It really does unlock all of those use cases that we've talked about before. Real-time voice, real-time analytics, using Groq's JSON mode to parse out details and pull out fields from, really fast-flowing information flows. All of this, before was kind of in the realm of, prototypes and kind of toy projects, but now you can really start to experiment and see if this fits into your kind of enterprise use case. So now that we've kind of gotten a feel for, just how blazingly fast Groq is, we want, obviously we want our database to be just as fast to be able to keep up with Groq, because it's no use, if we're using a, super fast, LLM inference engine, if our bottleneck is the database, right? And the database is, operating on the order of seconds as well, right? Because that's going to be our kind of our limiting factor. But not to worry, with SingleStore and inside of SingleStore notebooks, that's going to really be the fastest way and the best way to get your code running as close to your data as possible. And so I'll just show everyone here how to really easily connect to their database using LangChain and inside of SingleStore notebooks. If you just run this cell, what we're doing is we're essentially importing all of these connection details that have been made available to us because we're using SingleStore notebooks right into the Python notebook. And so we just run this and immediately, we're able to interact with the SingleStore database. And what we're going to be doing today is we're going to actually be asking the Llama 3 model hosted by Groq about the Groq LangChain documentation, right? And the reason that we're going to be asking about this is that presumably the Groq LangChain documentation is not inside of the Llama 3 pre-training data mix, right? And so if we just ask Llama 3 traditionally about, how to use, Groq inside of LangChain, we're going to get, a hallucinated answer that's really going to get us and our end users nowhere, right? But if we're able to augment the context window of our LLMs with relevant and factual information, our LLMs can in turn give us, relevant and factual responses, which if we're using Groq, it can give us those responses on the order of hundreds of milliseconds. So we're using a few LangChain abstractions here to load in this web page. Here we're using just web base loader, which is just one of the built-in LangChain data loaders that takes in a web page as an argument and then loads it into LangChain. And then once we've gotten the raw data into LangChain, what we're doing is we are splitting it up into chunks, and then we're taking those chunks and we're turning them into vectors. And like I mentioned earlier, vectors are the way by which LLMs are able to search over our AI contextual databases by semantic meaning, by the meaning behind the words and not by the exact keywords. And so happy to answer more about that, though I'm sure we'll have a lot more questions, but I'm just going to go ahead and run some of this. And here we'll just spin up our database. Using SingleStore inside of LangChain, it's just one line of code once you've gotten your document splits to ingest a database. And then we're going to run, a retrieval QA chain inside of LangChain, which basically simplifies the whole step of retrieval and augmentation and generation into one line of code. And that's just going to be giving, our query, please show a simple example of how to chat with Groq with LangChain and Python. Oops. Let's see. I'm going to do this. Groq. And we can see very quickly, it gives us a result. Here's a simple example of how to chat with Groq using LangChain and Python. And just for curiosity, let's take a look at how fast that is with OpenAI. And you can see that's like almost, Groq answered in about 1 second. OpenAI took almost 5 seconds to give the same response, right? And so, obviously there's kind of differences in terms of, the models used. And that's actually in this case, we talked about this in our last webinar. Llama 3 is actually a more performant model than GPT 3.5, if any of you can believe that, right? And so you're actually getting better performance at a faster speed, which is, I think, just incredible. As an AI developer, that kind of has me jumping out of my seat. And so now we'll kind of get into the questions here. Let's take a look here. Akmal, anything that jumped out to you?
Yeah, just a couple of questions there, Alex. I don't know if you think Suleiman has a question there. I think he's been waiting a little while, almost 6 o'clock. He asked it, if I can quote him. He says, "I will recommend to talk about LVM and how we can use it in different computer vision application." We kind of touched on that a little bit for the question that was asked. I think it was Bruno, but I don't know if you know much about that space, Alex. It's a little bit beyond my knowledge.
Yeah. So, Suleiman, I would recommend checking out um, our webinars on multimodal LLMs. We've done it. We've done a demo both with LangChain and Llama Index. And so, for those of us unfamiliar, LVMs, language vision models, are basically kind of the newest generation of models. Multimodal models are essentially able to take as input, not just text as we've seen here, but also images. And so, you know, the models are able to reason over the contents of images and what's inside images and what's not inside images. And so I would definitely recommend checking out those webinars, Sulman. And for anyone else interested in multimodal or vision language models, those are a great resource. Great. Let's see. Lewis just asked, Alex, can you please show or explain how to configure SingleStore to get the SingleStore DB URL? Great question. So if you are not inside of SingleStore notebooks, you will need to get this environment variable, SingleStore DB URL, from the SingleStore portal. And the way you do that is actually pretty simple. It just involves a few more clicks, which is why I recommend everyone to kind of get started prototyping inside of SingleStore notebooks. It really is the best way to kind of get prototyping with SingleStore and some of these Gen AI applications. But if you just go under your Cloud tab here, you'll have created your workspace. And actually, I'll show the starter workspace just as an example. Once you click inside of your workspace, you can click Connect, then Your App. Oh, actually, we'll just go to a workspace that I've already set up here. Connect Your App. And then you can see here, the first time you connect, it'll show you, and you just go to Python/MySQL connector, it'll break out all the details that are relevant for you. But the first time you set it up, it'll show you a password that you'll want to make sure to save. And then you'll use that password as well as the username, the host, port, and database name. So the database name, is going to be the name of whichever database you're interested in using. You're going to want to make sure to take all those details over to your notebook development environment. If you're developing locally, you'll need to do this. If, for example, you're like running this in Visual Studio Code, you'll need to make sure to do this. And then you'll just paste all those details in under this SingleStore DB URL environment variable. So your username, password, the host, the port, and the database name. Great. Okay. So Aftab Faruqi asks, can you show/share code used to show the exact citations in the documents? So I know that the functionality does exist in LangChain. Off the top of my head, I don't recall the exact argument that you use to enable it to return a response containing citations. But the functionality 100% exists inside of LangChain. It's probably actually just an argument that you can just provide inside of the retrieval QA chain. But just for the purposes of the demo, we're not using citations today, but do feel free to explore the LangChain documentation. It's very extensive. There's some great documentation on, not just how to use a SingleStore connector, not just how to use Groq, but also some of these RAG use cases. There's a lot of different ways to customize it. Great. So let's see. Omar asks, did you try agents framework such as Crew AI or AutoGen with SingleStore and Groq/Llama 3? So I don't believe, Akmal, do we have a webinar on AutoGen?
Not at the moment, but
Yeah.
that might be a great suggestion to do on, Alex. So thank you, Omar.
Yeah. So I don't think we have a webinar on AutoGen quite yet. But
No, no, yeah.
yes, so in principle, this is 100% possible.
Yeah.
AutoGen and Crew AI are both frameworks or LLM agent frameworks that are agnostic to the actual LLM being used in the backend. And that's the really nice part of using, as a connecting layer, these LLM orchestration frameworks like LangChain and LlamaIndex. They make it really easy to swap out. And you just saw how I just swapped out, OpenAI here for Groq, just to show, the kind of difference in inference speed. They make it really easy to swap out. Like say, for example, if AutoGen uses GPT-4 as a default, you can set it instead to use Llama 3 over Groq as an LLM instead, and kind of see how that performs for your use cases. Okay. Let's see. So let's see. Glycemia asks, how much data would we then require to the use of SingleStore? Obviously not just a website page, right? Yeah, great point. This is just for the purposes of the demo. We're showing, a pretty toy example of, how to use Groq to interact with information that was not made available to it during the training process. If you have your own kind of use cases in mind, hopefully from this kind of pretty simple use case or pretty simple example, you can extend and see how Groq could use how you could use Groq to chat with your entire company database or or kind of the larger corpus of documents that you're more interested in, vectorizing, storing, and then having an LLM understand. So at any one of these steps, you could kind of scale any of these steps out horizontally by 1,000 times or something. And that's really where the power of SingleStore comes in. Let's see. Deval asks, Groq's astonishing speed is truly remarkable. It makes me wonder why OpenAI and like others aren't harnessing similar techniques to enhance the speed of their systems. It's a fascinating concept to explore. So yeah, I mean, really great observation, actually. I just off the top of my head, I know that Groq's proprietary chip is actually not that efficient for larger parameter count models. And so you'll see, Groq is great for running, Llama 3 8 billion parameters, which is, it is already rivaling, OpenAI's cheapest available model, but it doesn't quite reach the kind of performance of some of these bleeding edge models like GPT-4 or Claude 3 or Gemini Pro, right? And so, at the frontier of model performance versus latency, you're going to see, you're going to really want to make sure that you're using the model that's not just the fastest, but also, the most performant, most capable of reasoning over your data. And that might not necessarily be Groq. Thankfully, if you're using GPT-4 or you're using, Claude 3, we actually have webinars for both. We just recently did a webinar on Claude 3, which is the newest frontier kind of bleeding edge model released by Anthropic. If you use any of those models, you can also use SingleStore and have your SingleStore database able to interact with those models, right? And so, like I always say, for those of you that have, come to more than one of my webinars in the past, it's always going to be about, making sure that you set up a standardized benchmark over the task that you're interested in, the kind of work that or test of the work that your proprietary data is most likely to be used for, your company is most interested in, and then testing, multiple combinations of, open source LLMs versus closed source LLMs, bleeding edge LLMs, testing combinations of, fine-tuned versus off-the-shelf embedding models, right? Testing different prompts and fine-tuning your prompts, right? It's usually pretty simple to get the kind of most basic examples up and running. But the hard work is really going to be in the actual benchmarking process, right? Making sure that you're really squeezing every last drop out of your RAG pipeline. So everything from the LLM to the embedding model to the actual, the prompts that you provide to the model. Sorry, that's a kind of long-winded response to just a comment, but really cool observation. Okay. So Glycemia asks, how would that compare to just using the context of LLMs? So that's a really great point, actually. For smaller examples like this, you may well be able to get away with just copy and pasting the entire website or the entire PDF into an LLM context window and then asking your question, and you probably will get a pretty good response. The use cases where that doesn't work out, however, even though LLM context windows are fast becoming bigger and bigger, is that databases and data lakes will always be bigger, and there will always be enterprise use cases where the entirety of the database kind of far outweighs the context window of the LLM. And not just that, but when you're using these LLM API providers, they often charge by not just the output token, how many tokens that you get in response, but how many tokens were put into the input, right? And so if you're interested in asking, or you're asking a pretty precise question, say, for example, oh, how do I change the model for, the Groq, how do I change the model for Groq and LangChain, right? It might be overkill to actually copy and paste in the entirety of the web page, but if you vectorize the web page, you split it up correctly, and you have a performant enough RAG pipeline, your RAG pipeline will be able to pull out the exact, piece of code that's relevant to the user's query, and then only those, 100 tokens or whatever compared to the 1,000 tokens of the web page gets put into the LLM context window alongside your user's query, which then gives you the same answer, if not a more accurate answer, because LLMs get confused by longer contexts, for a much lower price, right? And so number of different reasons that you might be interested in using, a database to store your vectors as opposed to just stuffing it into the context. All right. So Jawad asks or mentions that Llama has a small context window. Does it have an impact on the quality? So if you're interested in kind of the actual benchmarking results of Llama, I would highly recommend checking out our webinar that we just did on Tuesday. Long story short, not really. Llama 3, the newest Llama release, is actually more performant and better than all of the open source models that have been released so far, even better than the kind of fastest and cheapest open source models being made available by OpenAI. As far as the context windows goes, I believe there are already fine-tuned versions of Llama 3 that have up to 1 million token context windows. I think the base model released with just a 8,000 token context window. Sorry. And so, if you're interested in longer context open source models, I would highly recommend checking out Hugging Face. That's a really great resource for that. All right. David Burton asks, Groq uses custom hardware. The Groq card only has a small amount of memory, so the 70 billion models apparently use 576 cards, so it's a pretty expensive cluster. So they're more limited on input tokens supported as a result. Have you got any references, aside from RAG, on how to reduce input token lengths For example, prompt tuning instead of longer prompts. So there's kind of two main ways to reduce your input token lengths. And really, you just mentioned the two big ones, right? The first is going to be making sure that your RAG pipeline is as airtight as possible. But what I mean by that is that what it spits out on, after taking in your user's query, what it spits out on the other end is not just, relevant, but also extremely, or it's not just somewhat relevant, but very specific to what the user's query is trying to get at, and kind of returning the minimal possible context to support the user's question. That's a very hard problem that many people smarter than I are working on. And the kind of the steps you take to get there are all the ones that we've just been talking about. You're going to be you're going to want to look at your embedding model. You're going to want to look at your chunking method, right? You're going to want to look at, here we're using the recursive character text splitter, right? That recursively splits each chunk by new line characters. But, you might want to look at, say, for example, a small to big text splitter, which, splits out by sentences or even like by only a few words. But then when you return the actual context, it returns and blows up to the entire paragraph or a chunk of paragraphs, right? It's always going to be a trade-off, because if you're returning less information to the LLM, it's going to be, if it's not the exact information that it needs to provide the answer, it could very well hallucinate, right? And so it's going to be about benchmarking and then making sure, kind of every step in the process that adds in tokens to the context window is as airtight and as minimal as possible. So Luis asks, in the previous webinar, I used Replicate instead of Groq. He's checked that Groq is cheaper than Replicate for the Llama 3 8 billion parameter model. In such a scenario, what provider would you suggest using? Yeah, so I mean, it sounds to me like Groq would be the better provider to use, get all else held equal. I believe that Replicate allows for fine-tuning of the LLMs and to host a fine-tuned version of an open source LLM, right, for inference. And so in that case, you might find that, you're getting much better performance that's worth the extra cost compared to, just getting much faster inference speed. Maybe you find that much faster inference speed is not actually that critical to your use cases. Maybe it's like an internal tool that you're building. So it really is up to your use case, because I don't think Groq allows for hosting of fine-tuned models as of yet. But that might change. So, this is a really fast-moving space. That's why, I really do advocate the use of frameworks like LangChain and Llama Index. It's really going to allow you to stay super nimble and kind of be able to drop in and test out and evaluate very quickly in just a few lines of code of change, or just changing a few lines of code, the newest techniques and newest LLMs and kind of newest embedding models that are being released. Okay, I think we are running right up on time here. Yukti, do you want to announce the giveaway winner?
Hi, yes. Thank you so much, Alex. This was really informative. Do you have some of your demos left right now, or like,
Sorry?
is this done? Do you have something left?
Nope. I mean,
Awesome.
it was
Okay,
just
okay,
Q&A,
we're done.
so.
Okay. Guys, thank you so much for the overwhelming response. Please feel free to, put everything in the chat. We'll follow up with everyone via email. And okay, so Thank you so much, Alex, for joining, and thank you, Akmal, for hosting all these questions. And okay, so I have put everything in the chat. We have amazing topics coming up in the future, and if you guys are interested in any of these, please RSVP right now. So let me pull up the raffle winner for today. The raffle winners are randomly decided. So we generally use a randomized algorithm to pick one of the raffle winners from the list of our attendees. So yeah. Okay, so the announcement that you all have been waiting for, today's raffle winner goes to Venkat Gosukunda, who's the big data solution architect at Wells Fargo. Congratulations and thank you so much for joining. And if that's not you, please do not give up. We are going to announce one more AirPods winner and Meta Ray-Bans winner by the end of the day for anyone who has tried today's demo. Please sign up for the link that I have put up in the chat, and you can be eligible and be entered to win. Thank you so much, Alex, for the presentation and the demo today. Thank you everyone for joining. We really value your time and energy, and we hope to see you in the future sessions. Thank you. Okay.